And these all have, my name is Evan Colin,
And my name is Yuhao Ye.
and we are creating an imitation of a social media platform. What we want to do is we want to be able to notify users whenever their password has changed, since that's a practical function. And the way that we would use Merkle trees to do that is whenever any password is changed, we can quickly find which password has been changed in the email attached to it, and then we can send that user an email. So first, we're going to talk about the generic user class. This is an abstract class, and it has the base things that every single class is going to have. Obviously, with just your basic getter setter functions, there's not a lot going on in the users class because all of the interesting stuff happens in the types of classes. So these inherit the user variables of email, username, password, but they have their own unique variables. Business, for example, has business location. Um, Personal has birthday and a job. And if you're a celebrity, it has what you're known for and a link to your website. And these all have their own constructors. Um, they all set their display names differently. So a business location will be the username and then the business location. So if you are Walmart down the street, then your display name would be Walmart down the street. For personal, it's just your name. And if you're a celebrity, then it's going to be whatever your name is plus whatever you are known for. Next, we have the Merkle tree class.
Okay, so I'm going to show our implementation of our Merkle tree class, and our class have the three variables and they are all the users, string information and also the root value. So the root value is obviously to store the root hash value of the root of our Merkle trees. Okay, so the first thing I want to introduce is all the user function. It's all the user member variable. So in our driver, and we create an instance of our Merkle tree, and then we pass a user, which store all the informations of all the users and a user's password and their email, and then we pass it as a parameter or into our constructor. So in the constructor, and we assign this user to all the users. So all the users is exactly the same as the user we created in your driver. Okay, so the next variable is string information. The string information is only used inside another function, which is update informations. And in the update informations, and we access every user's emails and password, and we concatenate the email and password, and we push the result of the combination of the email password into our string information. So the string information basically store all the users, the combinations of the email and the password of all the users. So if you notice, you will find that our method is private functions. So it is only, so we only call this function, we only use this function inside another function, which is a get Merkle root. In the get Merkle functions, we don't have the parameter, but we have we only have the one root value. So before we get our root value, we have to do is we have to construct our Merkle tree. So our Merkle tree, we use the insert function to construct our Merkle tree. Okay, so before I introduce our insert function, I want to introduce another two function, which is sh256 convert and merge hash value. In the merge hash value functions, we accept the two strings. The first one is h1, the second one is h2, and then we concate these two strings, and then we pass the result of their concatenation into sh256 convert function. So this function is kind of an algorithm that can convert a string to a SHA-256 hexadecimal hash value. So the last method I will talk about is our insert function. So, and we draw our design of our insert functions. So at the bottom of the functions, at the bottom of the image, it is string information. So because in our function is a recursive functions, and in our get Merkle tree, we pass in string information as our parameter for the first recursion into the insert function. So the linked list at the bottom of the image should be the string information. Okay, so the next program will iterate from the first element, and then it will keep on merging the element and its neighboring element, and push the result of the concatenation into a merge hash value, and then we will push the return value of this function back to a new list, which is update. So this update linked list just store the hash value. Okay, so after we iterate every element in the linked list, and then we reach the end of our first recursion. So at the end of the first recursion, we pass this update list as the parameter to our next recursion. So I think our code exactly reflects our design. The first of all, what we do is we define a basic case. The basic case means that if the size of the linked list we pass in is equal to 1, then we terminate the functions and return this value directly. So like what we do in our picture. So if there's only one element left in the update, then we just return it directly. So okay, and then we create an update which is store the hash value, and then we iterate from the first element and apply the merge hash value on it and push it back to the update, and then we push this update to the next. We pass this update to the next recursion. Okay, that's it.
So moving on, we're now going to look at our driver, which covers, the rest of the functions. So initially, I just create some test cases for the different types of users: a business, a celebrity, and a person. And then the first thing that we want to do is we want to read in from a file, which is acting as our database. So here we're using it in a CSV format. So the first row is all of the types of the information. So every row after parrots this. So the first entry is always username, then password, email, and then the type of the user. We decided not to get super robust with this just because reading in the data wasn't the point of the assignment, but the Merkle tree. But it acts as our database is the point. And so I'm going to go ahead and run this just to prove that it works. And now we get to this part where we read in the file. And then through here, what we do is we take we use a buffered reader and a file reader to read one line at a time. And then we separate the values by the commas, which were given inside the file that I just closed. And we are able to put these into each specific spot. Moving on from here, we get back to what you had gone through before with the Merkle trees, and that we initially create a Merkle tree with all of our users inside of it. And whenever you print it, we get this first hash. Now, whenever we change the password, which is what occurs right here, I just change password to new password, we get to see that the hash has changed, which would be correct because obviously if one thing changes, everything else above that will change. And because the email is linked to the password, we also just wanted to show that if you change the email, then the hash changes as well. So these are 3 different hashes because they're 3 different iterations of the Merkle tree. Next, we go into printing the database. And so after we read in the information and we modify it in some way, here what I'm doing is I'm adding in the display names, which change depending on what type of class it is. You can see everyone's outputs. And so first I show the class that it is so that we can guarantee that the display name matches up with what we said it would. So we have 2 personal classes where the display name is just their name. That's me and Yuhao. And then the celebrity, we have Taylor Swift, who is a singer and actor. We also have Johnny Depp, who's also a singer and actor. Next, we have Walmart, which is on the corner, Target on the corner, so username and location, as well as the generic information that everybody is going to have over here. Lastly, we want to write this information back into a file, and that can be seen here, which will mimic what we've already done when printing the database, except that now we have it in a file, so that way at a later date, we could read it in again. And we could do this in comma spliced format, but we wanted to do the output in a way that would be much easier for people to read, and we can update the input file at the same time. And so that is our project. The last thing that I wanted to show was the UML diagram showing that we did it like we had planned. That the Merkle tree contains the user, and the users, or the different types of users, are all children of the user. And here it shows that the display name is going to change depending on what type of user it is. Okay, and that should be it.
Thank you.
I wonder how long that was.
I think it should be like 6 or to 7 minutes, I guess.
We probably should have recorded, because it's gonna suck if that's like 4 minutes. No, that's definitely over 5 minutes though, right?
Yes, I think it is beyond 5 minutes.
Okay, then I'm gonna end the call.